Yeah, welcome back. I hope you had some pizza and some drinks. And I'm going to start off track one with the technical deep dive, and Jerry will proceed and show a little bit how to build on top of Ocean. And I'm going to show the different Ocean components a little bit. We already talked about Keeper contracts, and Keeper contracts is Ethereum based. So we are on the Ethereum protocol, on the Ethereum tech stack. The contracts are written in Solidity. And the Keeper contracts are basically the backend for the whole stack of Ocean Protocol. So this is the heart of the Ocean. It connects to a secret store from Parity that is a decentralized key managing system that we use to encrypt and decrypt access keys to data. The Keeper contracts package is available on NPM, Maven, and PyPy, and is written in, or is supporting the Web3 version of JavaScript, Python, and Java. And the Keeper contracts contains the service execution agreements that Marcus already talked about. We have some abstraction layer on top of our stack, which is called the Squid library that exists in JavaScript, Python, and Java as well. And when you want to interact with some Ocean components, use the Squid library, because we found out that data scientists don't like friction to access data, right? They want to use the data marketplace as smooth as possible. And we try to reduce friction. We try to reduce the need for knowledge of blockchain. In the ideal world, you don't even see that there is a blockchain involved when accessing data. And as a data scientist, using all of the top-level components, you should not use the Keeper nodes directly. And we already have deployed our mainnet, and this mainnet is a POA network. And I set by intention we are using the Ethereum protocol, because we are not using the Ethereum mainnet as it is, because there are many different instances of Ethereum right now. We are running our own, and for some reasons, because of stability and flexibility and performance and so on. So this is very, very bottom, very, very low level. If you want to only consume assets, don't care about Keeper contracts. This is we group those components by level, and the Keeper contracts and the secret store are level 1 components, which is the most basic components you can get. We are using the Parity secret store to store keys, and Keeper contracts are connected to that secret store. It is the secret store is not a blockchain, but it's a distributed system to store keys and to retrieve keys, of course. And again, we have different implementations in different languages to support the different tool sets of JavaScript, Python, and Java. We have, since April, our test network running, which is called Nyle. And whoever wants to build something against Ocean Protocol can do this against Nyle. So you can use it. It's public. You can get tokens on that network, and you can get Ether on that network, and you can just start building stuff against this network. And a few weeks ago, we launched our mainnet, which is called Pacific. And this is connected to the real Ocean token. So if you want to build a marketplace that actually leverages real Ocean tokens, you can do this against the Pacific network. And we have a bridge. That means you can transfer your tokens from where you have them in the wallet to the Pacific network to use them on the network. this is a component from a level above. This is called Squid, and this is our main library to interact with Ocean Protocol. This Squid library is using the keeper contracts to do stuff on the blockchain, to register assets, to do purchases, to hand over ownership of assets. And like it's written there, it is an abstraction layer of keeper contracts, and this is the way you do it. And we have a CLI based on the Squid library. We have front ends built on the Squid library, and this is the single point of contact. So if you want to do something lower level, not really low level, but lower level, use the Squid libraries. Again, JavaScript, Python, and Java. We have a component called Aquarius. I was just saying this earlier. It is a microservice connected either to MongoDB or an Elasticsearch to store the metadata of ocean assets. We got a pretty good documentation that is docs.oceanprotocol.com, where you can find all of those components, including their APIs and including what they are doing and how they are doing it. And during lunch, I was just talking about OEPs. As you can see at the very bottom of the slide, there is OEP 8 mentioned. We describe all of the changes to our architecture in OEPs. They are called Ocean Enhancement Proposals. And so the whole architecture and how Ocean is working is documented in those OEPs. They are publicly available and open source. So if you want to read them, you can. Another component is Breesaw. It is the publisher. That is the component you actually get your data from. If you buy a data set on Ocean, then this component will stream this data set to you. It is usually connected to cloud providers like Amazon or Azure, Amazon Web Services, sorry, and Azure, but could also be easily extended to use on-premise storages or other storages. I'm very proud of this component because this is the most powerful tool that Ocean has. It's called Barge, and a barge is something that rockets land on nowadays. It's not the rocket; it's the float on the water, and you can run the whole Ocean stack with all of the components I'm just showing on your local machine. It's just one command. It's start ocean.sh, and then it will run the Ocean stack on your machine. This is super convenient when you try to build something on Ocean. Then it will just spin up all the components, and you're ready to start coding. And it's pretty easy to use. We have a collection of boilerplates and samples that you can copy to build marketplaces or to build out different other components, and they're all in the Tuna repository. This was initially planned as an comprehensive test suite to have a set of tests that you can run against your architecture and see how it behaves, but you can really use it to copy the code for your use cases. So if you want to build something on Ocean, then this is a good idea to check. Oh, that's an old photo, man. We launched the Commons Marketplace a few months ago together with our mainnet. It's reachable on commons.oceanprotocol.com. And this Commons Marketplace is connected to our Pacific network or mainnet, and you can get an idea of how a data marketplace could look like. This is run by Ocean Protocol, and this is containing only open data sets. So all of this data is public, and there is no You don't have to pay Ocean tokens to access this data. All of the data sets are free. And right now we have more than 1,400 data sets registered, and can be a good example on how to build a marketplace. Jerry is showing in a few minutes of us how to do something similar. We have an integration into Jupyter Notebooks that is called Manta Ray. You can find it and try it out on datascience.oceanprotocol.com. You can basically spin up a new Jupyter Notebook with the whole Ocean stack integrated, and then you can search for data sets and consume it directly from your Jupyter Notebook. Ocean Protocol is open source, so everything that we're doing is open source. We have like 67 repositories now, which is quite a lot. And it's quite comprehensive. So we made a good work into open sourceness. The documentation is available at docs.oceanprotocol.com. Yeah, let's build on Ocean. Yeah, I was already showing the slide earlier. This is pretty cool because we're giving away Ocean tokens as an incentive to build on Ocean Protocol. So if you are someone who is able to build a marketplace, do it. You can earn money and you can earn Ocean tokens with it. That's it from me. Jerry will now take over to show you how to actually build a marketplace.
Code management. I thought at the beginning the idea was that like data providers, data analysts would in fact actively participate in the network. So I understand that for the most part they are interested in just going to the Manta Ray and playing with the Jupyter and having access to everything. But for those of us who are here, probably we would want to be more at the forefront of the development of Ocean Protocol, and therefore also run possibly our own keeper nodes to be in the network. And is that something that is doable today, planned, or or being discussed, or like what to expect in that front?
The incentivization model on running keeper nodes and everything above that level is in our white paper and is planned. It's not possible today, but there will be an incentivization model for all of the levels of the network. So you potentially can get an incentive for running a keeper node. You can get an incentive for putting data to the network, or for curating, or for publishing, whatever. But this is not in the current version of Ocean Protocol. But it is planned. It's in the white paper, and we're going to do it.
Hi. I'd like to know who are the nodes right now of the Pacific network?
The network is run by BigChainDB right now.
Okay.
Exclusively.
Okay, and will it change, or?
It will, of course. I was at the very beginning. I was talking about being a public utility network, so that means everyone can run a node. But it's quite some interesting task, because if we open up completely, then someone might take over. So we have to do this in a controlled manner, and we're going to onboard more authorities over time in the next few weeks, and then open up more and more. But right now it's run by one company, which is an anti-pattern in a decentralized world. Yes.
Okay. So, and are they the same nodes? Are they the same nodes as the secret store nodes?
Yes, but just in a different configuration.
Okay.
The secret store node the secret store nodes are parity nodes.
Yeah.
And the network is parity as well, but in a different configuration. Yes.
Okay. Thanks.
You're welcome.
So I'll be talking about the way to do, or let's say, do basic operations on top of Ocean with the least amount of code possible. So this this workshop will be okay for anyone who knows basic understanding of front-end. And I will go through what needs to be set up from MetaMask to connect to POA network and to initialize the ocean and to do basic operations on the ocean. Yeah, so first I'll be talking about requirements. So some of the requirements are, let's say, having your front-end network, having Node.js running locally, having a MetaMask crypto wallet connected to the proper network. Then I'll talk about the ocean and how to initialize and work with the Squid. And later, if there are any questions, and all the links to everything. If someone wants to already open, or let's say has computer and wants to have more information or look at this slide, he can already open it there. So these are the requirements. Like I said before, crypto wallet connecting to a proper network, getting the gas on that network from the faucet, having Node.js, NPM, or Yarn to install the Squid.js package, and environment setup. First is getting the crypto wallet set up and connected to the Nyle network. I will be using Nile network since that's the test network and we can freely test against it. We can also get free Ether on that network. So first we need to pick on the top to get drop-down list, and you choose the custom RPC, and then write in the URL to the Nile network. And then in the end we have on the top right we have the Nile network, and we are connected to the Nile network basically. So to do any operation on the POA network, you need to get some gas. So to get that, you can either use faucet that's part of the Commons Marketplace, that's the test network, or execute the terminal line below, which is basically the same thing, just executed locally. We are limiting the faucet currently to, let's say, I think 0.5 Ether per day. So, and that's basically enough to do any kind of operation. I mean, hundreds of operations on ocean. So if you're going to be building with your own custom, any front-end framework, then you need Node.js, install that framework that you want to use, and then use NPM or Yarn package manager to install the Squid.js. That's the only integration point that you need basically to do any operation with Ocean. So I'll be talking now about Squid.js. So how to initialize the whole Ocean, how to register an asset, how to search for assets, and how to consume an asset. So we have we have example code in the sandbox. So you can just open it in a web browser, and you can run all these that I'm going to be presenting now really easily. So if you open that link, you should get something like this, where you have code already loaded, and you can already execute basic actions. You can get this on the tinyurl.com ocean-sandbox. And I will be going through each operation, how it works, and what information needs to be provided with to successfully complete it. And I'll be jumping between either explanation in the slide and then showing the same thing, the same code in the sandbox. To initialize the Ocean, first need to import the Ocean instance from the package. Then we need a successful Web3 initialized object, which is either MetaMask or Burner wallet or any kind of wallet that has a signature engine and connected to the proper node. And then is the Ocean configuration. So in the Ocean configuration, you need to provide that Web3 objects. So the contract gets loaded over that connection. The node URI, this is the node that you're connecting to. So in this case, it's a Nile network, so it's Nile node. Reporting to Aquarius URI, to Brizo address, secret store URI, and in the end there is verbose true, which is the logging level that we want to pick to get as much errors that we want from the package itself. So if right now everything is set up to a Nile, but if you build a solution and you just change all that to a local node or to the mainnet, it's as easy as just setting different configurations. So switching between different networks is really easy. So to register an asset, we need to reference the ocean that we initialized before. We first get all the accounts that are available from the crypto wallet, and then we use that crypto wallet account and the asset to create a DDO. So asset is basically description of all information that is in the Aquarius, which describes basically the name, the date created, author, licenses, what's the price of an asset, all the files that are pushed inside of the whole DDO, and example links and language. This operation takes multiple signatures because here you're basically first extracting a public key from the account, then you create a service agreement, then you publish the asset on the registry on the chain and store all that metadata to the Aquarius. So by executing this, you basically do all the actions that are needed for registration. So I can now run this here. So when I click register asset, that function will be basically executed. So we got signature. You can see below that we are generating proof. We are registering the ID now. Proof generated, and we are registering the ID now. And now we're storing the ID, and now we get message that asset successfully submitted. And here the asset, we can see here the asset from the Aquarius, from the metadata store. So if I go back now to the next one, this is the searching for assets. This again uses the Ocean instance, and then you call whatever you want to search for. This is the most basic search that only does text search over the description and name of the asset, and you get back array of all the results that are in the Aquarius right now. So to demo that, I can search for asset here, asset successfully retrieved, and here I get all the results that are in the Aquarius. So the next one is how to consume an asset. This one is more complex. This is comprised from two parts. First, again, we get the account that we want to use. Then we get which service we want to use from the DDO itself. Right now we only have consume. In the future that will be compute, of course. Then once you have that agreement, you need to pay for it and fulfill all the conditions that are in the service agreements. And in the end, you consume that asset. So that is the request that actually provides you with the file that you want to download. And now I can start consuming. Again, on the bottom we see creating agreement created, agreement initialized, locking payment. We confirm the transaction. So what the consume flow does is you go through all the conditions that are there, and now we have payment was okay. So the next request will be to consume the asset. or we have permission, so we can download it. Access granted, consuming files. And there we get the file. So this is a streaming file. At no point we get the URL of the file. This file can be on-premise somewhere already. And the Breezo is basically acts as a proxy and only gives you file if you fulfilled all the conditions in the agreements. So what you get is basically a stream of file, not the URL of the file. And I have my file back. Any questions? Yeah.
As a consumer, my tokens are associated to my DID or to my public address. Or what happens if I lose my key?
Key to your address?
The key that maintains my tokens.
Well then.
Okay, so as a publisher, I have a DID, but my tokens are associated to my address.
Everything is associated to an address.
Okay.
And to a wallet, yeah. So your tokens are connected to your address in the wallet. The same are DIDs. So you prove that you're owner of an asset on chain or asset that's in Aquarius store by you signing a message. And from that we can extract what's your address, and we can check that address and match it against anything.
Okay, so but, if I have several addresses, for example, with the same DID, can I pay with one of these addresses and get the document with any of my other addresses?
So if you switch in crypto wallet to any other address, you can consume with other address the asset. Yeah, I mean, you can switch between other accounts or addresses without a problem.
Okay, thanks.
Okay, then that's all. I only have more links. So we have what was presented and more, even how to set up your own private local network. On Ocean Docs, there is a Create React app in which you can just clone and get the basic thing running. Of course, there is the sandbox that I just showed when you can already click and get all the actions running. We have Commons Marketplace, which is the full UI built marketplace, currently only with free assets. And there is link to the slides. Yeah, thank you.